Okay, I think it's 11:03. Let's get started, and then I think we'll have more people joining as we go along. Yeah. Okay. Thanks everyone for joining today. Today we are on the 1st of May, and we are happy to have Max with us, as well as Natthawut. They're both from the Sri Raj Informatics and Data Innovation Center, Thailand. And today they'll be sharing with us more about SQLMesh and how they can be used to enhance the OMOP CDM data conversion. For some of us who've been through last year's community ETL mapping, we've realized that the SQLMesh tool was critical in ensuring that we get through the mapping. And today we'll be going a bit more details about this tool itself. Yeah, so over to Max and team. Thanks.
Thank you so much, Mukesh, and thank you everyone for joining me today. So, yeah, as Mukesh mentioned earlier, that last year we did a little bit of ETL, right? We tried to convert data from Singapore hospital into OMOP CDM. So the process when we want to use data, hospital data in OMOP CDM, we first start with mapping the logic, the conversion, the source to the OMOP specification, right? And then we produce a kind of document that we then hand this document to the developers, software programmers, developers. They write some codes to make a pipeline to convert data so that we have OMOP CDM ready for research, for analytics, for other uses. But the problem is that it's not straightforward as it sounds, because there are many ways that we can do the data conversion, do the ETL. We usually call it ETL pipelines or extract, transform, loads, right? And there are many tools to do that. You could write, scripts usually in SQL or SQL, or Python. You can do that as well, but oftentimes usually get pretty complicated because you're gonna have over 30 OMOP tables, and sometimes, for example, at my hospital, we have, I think, more than 50 or close to 100 source tables that we have to convert into OMOP CDM. That means it's not easy to manage, or that complications in the pipelines. So we need to find some tool to help us to manage this OMOP conversion. And some may use GUI tools like Microsoft SQL, SSIS, for example, but I don't like it because you have to click a lot to get to the, to the OMOP CDM that you want in the end. So we have seen a lot of new tools that are free and open source that we can use to manage our pipelines. And yeah, we have tried some tool in the past. We tried DBT and we made a poster on that as well. And over the last year, 2024, we tried a new tool called SQLMesh. And this tool has been very helpful to us to make our pipeline up to date. And we can make modification, we can add new data, we can add a new mapping to our pipelines, and we can also do the data quality control and all the checks. And so today I'm going to show you a short demo of how SQLMesh could work in your hospital. I am aware that I think many of us are also researchers and perhaps not ETL developers, but I think the concept is pretty interesting to me, at least. My background actually is a researcher as well. So I think you can learn something and hopefully share with the ETL developers. And I think, yeah, and I think it's a new tool to learn. And yeah, it is great for us. So we presented this work last year at APAC Symposium in Singapore. So we summarize all the technicalities about SQLMesh and DBT. And so I just want to quickly mention some of the key features. So SQLMesh is like a modern version of all these tools, and it can handle SQL language. It can help detect syntax errors, optimize performance, and you can write code once and run across multiple database dialects. For example, at our hospital, we have Postgres database, we have Microsoft SQL Server, we have Oracle, And SQLMesh can handle all the databases in one code base, something that DBT or custom SQL cannot do that. So yeah, that's one benefit of SQLMesh. And also it can do column level lineage. What it means is that it can track all the changes that you make in the source data. So let's say we have hospital data, right? And sometimes some people add new column or change the column names, data type, for example. And that means all the information in that column has to be updated in our pipeline. And SQLMesh help us. It tracks all the changes in the column. And when there are any changes, it's going to warn us that okay, we have some changes going on. Do you want to refresh the whole pipeline? And it will help us refresh, update the data. It can help us with the environment management when we have multiple developers in the teams that do the same pipeline. And so we can create a development environment. We can create a testing environment to make sure that we have correct transformation before we push the changes to the production environment. We can also do incremental loading. So for example, when we have like a large hospital database, we have million patients in our database. And when we do any changes in the database, it takes time to run the code, right? And we don't want to do that all the time because they're gonna, takes a long time. So we can do incremental loading by using unique key or time range. So for example, we have the data 10 years. Let's say we have 10 years of data. We want to make the change of only the last year. We don't want to do the whole 10 years. We can do that as well with SQLMesh, and it's pretty easy to set up. We can do data validation. We can do versioning. You can use GitHub. You can use source code version control so that you can track all the changes that you make in the past and manage all the, make the code easy to maintain for the future. So this is a comparison and some diagram that you can check on our poster. And I sent this GitHub link into Microsoft Teams chat as well, so you can follow me. And when I'm gonna show you like this step on how to set up SQLMesh on a demo dataset. So we will be using a dataset called Synthia. So Synthia is a synthetic dataset that you can generate a synthetic patient, and there are works in the communities that use DBT as a tool to do the ETL from Synthia to OMOP CDM. Or you can also do the ETL using R and SQL script as well. This one is also on Odyssey GitHub. I put the link in our repo already, so you can check them. But today we're gonna use SQLMesh. So what you need is just Python and a database engine. In this case, we're gonna use DuckDB, which is a very simple database that you can run on your machine. You just install. It's free, and you can install it on Mac OS, on Windows, on Linux. There are many ways to install it, so it's pretty quick. So just follow that installation, and then I think hopefully everyone has Python installed on your machine. Otherwise, you just have to find how to install it, right? So let's try this together. Let me create a new folder, and we can go through this together. Hopefully, we will finish before the hour ends. Anyway, so let's start a new terminal. So I have let's create a new folder. So APAC SQLMesh, right? So now I have just an empty folder. Then let me zoom in a little bit. So we can just copy this command. So Python create a virtual environment. So we're gonna have this virtual environment. We can activate it. So just copy this command. Then we are in the environment. We can then install SQLMesh. Interesting. Let's install SQLMesh first. All right. And while we are waiting, SQLMesh has really nice documentation that you can follow on their website as well. Again, everything is free of charge. You don't have to pay. It's just Python package. That's a little bit weird. Oh, I forgot that I have to include the quotation marks as well. All right, it should work now. I will update the manual later on. Where is I lost it? I have so many tabs. Oops, I think it's this one. Okay. Sorry about that. And then we have SQLMesh installed. Next, we will initiate the directory. So we just write SQLMesh init.db. So you can use other databases as well, like Postgres, Microsoft SQL Server, and etc. But in this case, we're gonna use DuckDB for demo. I'm gonna delete some of the example files that we don't need, and you can keep them if you want, but I'm gonna delete it, right? And then because we gonna use ETL, we're gonna use Cynthia data, I'm gonna take the data from that has been generated already. So in this repository, there are this file of CSV. Basically, there are CSV file. Let's see, patients.csv. You can see it's just a simple CSV file that has patient information, but it is not in OMOP CDM. Our goal today is to convert this Cynthia data format into OMOP CDM. Right, so I'm gonna quickly copy these files into seeds folder. I am going to see whether I can find it or not. All right, so okay, so it's gonna be these 3 folders. I'm gonna copy all of them, put them in our folders. Oops, I don't do that. Let's do this one and then please. Yep. So now I have this CSV file in the seed folder, right? Let's get back to the step that we have here. So we can, so in production, we are not going to use the CSV file. We're gonna connect SQLMesh to live databases. But in our demo, we're just gonna use CSV file to make it simpler, right? All right, then we can load this file into DuckDB. Right now, it's just a CSV file sitting there, right? So we can specify that we want to load this seed. So I'm going to create a new script in seed, in models directory, and then seeds. And then I'm going to create a Cynthia allergies. So the first file is called allergies.sql. And I'm going to copy this command. I'm going to explain what it does in a moment. So this command tells SQLMesh that you will need to create a table called Cynthia.allergies in DuckDB database. And then we want to take the data from this CSV file that we just have, that we just pasted earlier, right? And then we can also specify the column types as well if we want to. It's a good practice to specify column types because we never know what's going to happen with the data types in the source data. And if there are any changes, SQLMesh will warn us that, okay, there are some mismatch in the data types. So we have to correct them before we go any further with the pipeline with the ETL pipeline, right? Once we have the model specification written in the SQL file, we can run SQLMesh plan. And we want to do that in a development environment first. So we run SQLMesh plan dev. I'm going to run it. So it will ask, okay, do you want to run this? Yes, from the beginning of time, and then backfill mean fill in the data from the past to the present time. It's gonna run. All right, that's finished already. So what it does is that it create this database file, and what you can do is that you can ask SQLMesh to fetch the data from this database file, right? Something is wrong. Okay. It has to be Cynthia dev because it's a dev environment, right? So I have to change that. Sometimes, yes, it's annoying when we have many environment, but that's good practice to do. Cynthia dev. All right, now we have the data printed out in the command line. But if we don't like that, we can do use DuckDB UI to see the database. So I can run DuckDB-UI, and then it's gonna open this website, and then I'm gonna attach the database. So our database is the db.db database, and then it's gonna be in Cynthia dev allergies. So we just created that. So DuckDB will create this summary. You can see all the data columns, the distribution of the data. If you want to see the data, you can do that as well. So you can click the option here and then query in current notebook, and then you see all the data in the table here. So you see this information about allergies of the patients, right? Right. That's brilliant. We have loaded one of the table, but we still have a lot of table to load. So I'm gonna copy the code that I have already done so that we don't spend much time here. So let me copy the code. It's model seed. So I have all the seed ready. All right, I'm gonna put them in model and seed. Oops. Let's work. Not this one. This one. Let's try this. And then replace. All right, now I have all the SQL SQL script to load all the CSV file into our database. So you can see here that we have all the Cynthia, all the OMOP vocabulary script as well. So similar pattern. So we just tell the file direction, the file location and the column types, and then we just load them. Right. Usually in production, we don't add like all tables at once. We usually add the table one by one. So it's doable. So it's not that tedious or laborious to do everything at once. And once we have all the script ready, we can just run. We have to exit the database first. So we're gonna do Control D or type exit here. Hopefully, nope. Let's work. Nope. It doesn't work. I don't know how to exit this. It has to be Control. It's Control D. Oh, I make a mess. All right, I had to activate the environment again. Yeah, you get nervous when you present and all right, we are back in the environment, so we can run SQLMesh plan dev. Again, it's SQLMesh will detect all the changes, and will ask whether we want to apply the changes on. That's weird. All right, yeah. So we're gonna apply all the changes. Yeah, if there are any errors, they're gonna output them here. Some error are just a warning message, so it is fine to ignore them. But some of them are fatal error that you have to fix before you proceed. So yeah, but it just output everything so you can check later on. And once you are happy with the development environment, you can apply it to the production environment. So you can do SQLMesh and then plan. This will apply the changes to the production environment as well. So that's done already. That's pretty quick, right? Right, next step is to modify. So the first part is just loading the data into the database, and we did that already. Then we can do some data modification. For example, we want to change the column names. For example, we want to change start to allergy start date, for example. We want to change patient to patient ID. You can do that. You can do all the SQL operation, join, calculation, filter, aggregation, everything. So the idea is that we then create a new script that tells SQLMesh to generate this new table or view. You can define it as a view, right? And then you can define all the columns, column types, the metadata, the column description, and yeah, and then we can try this together. So we copy this code, and then I'm gonna create a new folder in the model directory. So we're gonna create a new folder called staging. And then Cynthia. New by staging Cynthia. So I follow the practice that folks have done in DBT ETL earlier, so you can follow them as well. So I just took their script and modify them a little bit so that it works in SQLMesh. And yep, all right, I have the code now in this directory. Then I can just again run SQLMesh plan and def like earlier. All right, it's gonna tell me that, okay, there is a change. Do you want to fill in the data? Yes. Or in this case, perhaps I don't want to fill in the data. I can, answer no. Or I want to use the UI. I don't want to use the command line because I don't know what's going on. I can wait a moment to watch. Oh, okay, I have to close this one. Give me a moment. What's going on? All right, I have to kill other process first. Give me a moment. All right, so I just asked SQLMesh to run its UI web page. So you can click here and then you're gonna get this beautiful UI to tell you what's going on in our code base. So we had the seed model earlier, we had the staging model in Cynthia. So for example, we just create the allergy model, right? And you can click here and you can see all the code that we have earlier. We can also see the data lineage. So this allergy code takes the data from the seed that we loaded in earlier. So we loaded data from Cynthia.allergy. So it's gonna be this one, right? So we have this one, and then we load them into this one. So you can track all the changes, the lineage of the data. Then you can plan, and then you see again the changes that are being made, and you can apply the change and backfill the data. Boom, it's done. That's pretty straightforward. Here you can also see if you click on the left on the second button here, you can see all the script, the source code that we have earlier, the compile query. So the query that is sent to the database, it's gonna be compiled like this. You can try this. You can copy and then run this against your database as well. You can see all the description on the website, right? All the metadata, the explanation, the description. What else you can see here? You can see if you click this hamburger menu, is a little tiny button. You can see the data itself. You can click evaluate and click evaluate. Then you're gonna see the data loaded onto the web page. Right, so you can see example of the data here. And you can see the difference if you have multiple environment. When you make changes, you can compare them between production and development environment, for example, so that you can, okay, what changes that I made when I do the data transformation, so that I understand what's going on in the data pipeline better. All right. All right, so we don't have time to go through all of that. But it's a nice feature that I want to mention. Let's go back to our model, our demo. So we finished the staging. So I'm gonna cheat a little bit by copy the code that I made earlier and put them in our demo. So we had the staging. So I'm gonna copy everything once so that we have everything in place. So let's do that. Replace. And okay. So next one, we gonna modify the data a little bit further. In ETL pipeline, we usually call this intermediate model before we get to the final model. Again, we can do all the SQL stuff, and in SQLMesh, like DBT, we can do macro as well. Macro is like if you have repeating codes that you want to use in many scripts, you can write a Jinja macro to like a function in Python in R. For example, this is a save hash function that takes the columns and then it just coalesce the columns values and create a hash using MD5. So this is a Jinja template. What I'm going to do, I'm going to create a new SQL file in this macro folder called save hash.sql. And then so copy this one and then copy the code here and then put it here. And then when you want to use this macro, you can do so. For example, I have this intermediate model called intermediate location. So in this script, we use that macro to generate the hash for the source location source value by combining the address, one city, state, zip, and county together, so that we have unique location source value. And yeah, so I mentioned that we're gonna use Jinja query. So we just enter Jinja query begin and Jinja in. And then SQLMesh, we understand that it's gonna compile this into SQL script that we're gonna see now. So I'm gonna open the website again, the SQLMesh UI that we have earlier. Gonna pin this one, pin this. Okay. Oh. All right, so we have, oh, I lost it. Okay, so we have the model called intermediate and then location, right? This one and intermediate location. And so this is the final code that macro compile into. So it compile this macro save hash into this SQL command. And this will be run on your database. We can try this. So we can just click plan, and you're gonna see that we're gonna have more models like the staging and the intermediate model. We can apply changes in backfill. So what it does is just, run all the process for us, and this complete already. And let me find that demo link again. All right. So, all right, we finished the intermediate model. Then the final part, we want to convert everything into OMOP CDM. So we can specify the OMOP CDM columns, the data types, the description of OMOP CDM, the primary key, and we can also run some data quality check as well, the audit. For example, we want to make sure that the person ID are unique, so that we don't have duplicate IDs, right? And that is the data quality control that we want to do. And we gonna load the data from intermediate model. So here we load the data from intermediate person, and then we load data from these columns. All right, I can show the script here. So we have OMOP and then person. So basically we have all the tables. We have 30-ish tables in this folder. One of them is person. We have it here. Let's zoom out a little bit. Oops. Yep. So you can see that, yeah, we have the person, we have the observation, we have the the most complicated one would be the drug era. So this one you can do some more SQL scripting, and you can combine everything together, and then it's just gonna take the last select to create the table. All right. Then again, I can run SQLMesh plan, or I can run it on the website like I did earlier. So I run it on development environment already. I can check the changes. So let me check the changes. So I can do that using the DuckDB UI earlier, or I can also use some other tools like DuckDB, for example. I usually use DuckDB to work with the databases. So it can connect to many kind of databases. So, it's dbeaver. It's the program that you can connect to many databases, right? And it's free as well. There is a community version that you don't have to pay. You can download and install, and then you can connect to all these databases. DuckDB is one of them. So I just click DuckDB and then open the file that we created in the folder earlier, db.db, right? And then we can connect right away, and then it's gonna have this database open up, and then you can open OMOP schema. And the way that SQLMesh store data is that they store data in another schema called SQLMesh table. So it's gonna store data in another schema and has all the version ID attached as a suffix to the names. But when we use the data, it's gonna be in a schema called like the one that you specify. Like earlier, I specified the final model to be in OMOP schema. So you go to OMOP schema, and then you will find the data in the views, not the tables. But these views gonna retrieve the data from the tables in another table in this schema, but that's fine. That doesn't cause any performance. It's just the way that to make sure that we have version control for the data version as well, right? So we can see the person, for example. See here, we can see all the person, right? All the data is in OMOP CDM configuration specification. We can see condition occurrence. Yep, everything perfectly matches the OMOP CDM specification, right? Once we are happy with the dev environment, we can apply the changes to the production environment as well. We can just change the environment, and then we can plan. Does it work? If it doesn't work, it's gonna tell us why. So, I just queue the web server. That's why it doesn't work. So I can restart the web server, or I can just use command line. So I can just write SQLMesh plan, and then it's gonna ask me whether I want to apply the changes to these 80 something tables or not. Yes, I want to do that. Just apply the changes. It will update all the database tables for me. And yeah, that's all. And that's the start. And then we can do a lot of stuff with SQLMesh. You can do incremental loading. You can do the daily schedule. You can do all this. You can do test. And when we run this model in production, we use another command called SQLMesh run. We can try it. So SQLMesh run, but it will not do anything because it's just it needs to have data changes first before it take effect, before it loads new data into the database for the SQLMesh run to have any meaningful output. You can do many more stuff with SQLMesh. You can connect to the GitHub to run the pipeline automatically, or you can connect it to Airflow. And yeah, many tools have, it can connect to many databases as I mentioned earlier. So it's overall, it's a pretty nice, pretty neat tool that I would like to recommend the community to try. And if you have any questions, I'm happy, and my team, and Nongnapat is also on the call as well. We are happy to help you, convert your data into OMOP CDM with SQLMesh. Yeah, that's all for me. Thank you so much.
Thanks a lot, Max. It was really very helpful. I think very nice of you to actually do a full demo, right, on the live call. And it's not easy doing a live demo. So thank you again for your effort in doing a live demo for us. Any questions from the audience here today? Maybe I'll start. So we've used this SQLMesh last year during the ETL work we did as community, right? Were there areas where you felt definitely this tool helped us move fast? And then there were, of course, perhaps some parts of the tool that may still need some improvement. Yeah.
You mean the SQLMesh itself?
Yeah, SQLMesh itself.
Well, I think Nongnapat can help answer this because I didn't do the SQLMesh in the workshop, right? But I can answer for my production work. So I work in the hospital, and we convert our own data into SQLMesh. The problem is that well, SQLMesh is a new tool, relatively new tool. You can see its version is still version 0. So there are still a lot of bugs, the errors in the tools but the developers, they are very responsive. You can raise issues. I did raise several issues. I made some changes in their code base, and they are very responsive in promptly addressed all the issues. So that's one thing. And the problem is that perhaps a new tool as well, so it doesn't have a lot of materials that you can study. So if you are new to ETL pipelines, it's gonna be a little bit not easy to understand at first. But once you get the idea, I would say it took me around like a week to kind of get started onto using it, and about a month or two to fully understand all the bits and pieces that it has to offer. And but the idea, if I have if I can suggest, I would recommend newcomers to study DBT. So it's a similar tool, and DBT has been around a little bit longer. I think it has been around for 3 or 4 years. So there are more documentation, there are more materials on that. But like SQLMesh is like an improved version of DBT. So they learn the lesson from DBT, that DBT is like very compute intensive. It runs all the models. It doesn't understand SQL. So it's kind of annoying to work with DBT in a way, but it has a lot of good material that you can study. Yeah. Nongnapat, do you have any question before Cynthia asks any question?
Oh, should I go ahead?
You can go ahead. Yeah. If
Okay.
Nongnapat doesn't have
Yeah,
anything.
so I mean, you already started answering part of my question, which was like did you use DBT and how did it compare in implementation?
Yeah, so we can mention on that. Yeah, so basically DBT is good. It was a good tool, but the problem that we found was that it's very hard to change code. So when you make any changes, it's because it doesn't understand SQL. It kind of like, yeah, because you can see here it doesn't have like a SQL validation. So so when you make any errors, it just propagate basically, and it doesn't have like a separate environment. So SQLMesh, it has separate environment. Let's say I have multiple developers in a team, and I have a new junior developers that try to make some changes. And in DBT, you just push the changes to the production, and that's pretty scary. Or you have to create a new environment, and you have to maintain many environments, right? But SQLMesh, it kind of help you maintain many environments by itself, so you don't have to, create multiple environments. And because we work with patient sensitive patient data, we don't want to have multiple copies of patient data lying around, right? So we want to try to consolidate that. So SQLMesh has been very helpful with that. And yeah, it had many like column level lineage as well. So the DBT doesn't have that function. So when you make change to the some columns, SQLMesh understand that, okay, you don't want to rerun the whole pipeline. You want to just rerun some part of the pipeline. For example, the pipeline that we had earlier, let's see that pipeline again. It's going to be so complicated with both with the DBT and the SQLMesh. And when we use DBT, it took us a long time to reprocess everything. So for example, we have, let's see this, the most complicated one would be the drug era, right? So we have the lineage here, and you can see here is that it's like it takes data from many tables, and if you make any changes upstream or downstream, you're gonna have to reload everything. So it's kind of, yeah, not nice in a way that you have to full load everything. And yeah, this is the whole like ETL conversion for Cynthia, which is pretty simple data set, right? But when we deal with the hospital data set in our database, we have a lot more tables than this, and we don't want to reload everything. So we make use of that, and we also make use of the incremental load, which again very helpful in reduce the computation time. Yeah.
Thank you.
So I hope that answered the question. Yeah, so you can have a look here. So yeah, they have very nice lesson that you can like go through and try to understand. It's pretty straightforward. I think they make it easy to like follow, but it's kind of daunting in the like when you see it at first, but it's pretty straightforward concept.
Thanks, Cynthia, for the question.
Thank you.
Yeah. Right. Any other questions that we have? Looks like there are not many questions though.
Well, I'll ask another one, if I may.
Yeah.
So you've done then the ETL of the data at your hospital? Is that correct? And
Yeah,
how
that's right.
many unique patients are in there, and how many years of data do you have?
Oh, we I cannot remember exact number, but we have over 10 years of data. We have more than 5 million. Nonopat, can you answer help answer that question? I think more than 5 million patients. I cannot remember it anymore. But yeah, a lot of data, and yeah, and we have our code. Yeah, I can quickly share some of the code that we use. So, for example, we have like the demo that I showed earlier. We have the models, right? The same directories, similar but not the same. So we separate the models into the OMOP, the final OMOP tables. So we have the person table, for example, and then we have the staging that we, take the data, we rename, we do the calculation, we do the formatting of the date time, for example.
Mhm.
We trim, we do everything in SQL, and then we map. We try to we map them. When we load them into the OMOP CDM. So that's one table, for example. And then we do that for many other tables as well. So I think the patient count is not that bad, but the biggest trouble that we have is with the measurement. So we have many billion of lab measurements values. So that's take a really long time. And yeah, I think it took us many hours or days with DBT to run, but it take us like just so a few hours to run measurement, and we don't have to full load every time we do the incremental by time range, for example. So we just load the last 3 days, for example. We assume that there are gonna be no changes over last 3 days. So every time we run this, we load, today and the last 3 days, and that's it. So that save us a lot of time.
So how is your hospital using this OMOP data?
You mean using it for research, or?
Well, whatever use, what are the different uses of this data now? Is
Yes,
it
so
only
we
in
use
the secondary research, or is it also being used in some cases, like administratively, or in care delivery?
Yeah, we use it for mostly for secondary research.
Mhm.
Right now, initially we plan to use this for administrative purposes as well, but we find that we made a lot of logic, like the mapping logic that filter out some of the values, or change the way we handle the data that doesn't perfectly match the source database anymore. So it basically is good for research, but it's no longer good enough for administrative purposes anymore.
Okay. So what is your plan for, or are you already running research studies on this?
Yeah, so we have been running, we are trying to do the legend studies, for example, and we are open to many research studies. So we do hypertension, DM, several studies right now. Yeah.
Thank you.
Some fancy AI models.
Jivon has a question. Yes.
Oh, yeah. Thank you for your presentation, Max. From what you demonstrated, SQLMesh seems to it's a really good tool to time saving, but also it's really good for improving traceability a lot. And were there any specific cases that visibility helped, like a lineage like that, helped catch the critical transformation errors or inconsistencies?
That's right. That's a good question. Yeah, it helped me many times.
Oh, really?
And yeah, when I made any errors in data, I just look back and then, oh, what's wrong?
Mm-hmm.
Okay, let me allow me to trace the model back. Okay, oh, I made some mistake there. Then and then I know a little bit more. Okay, everything else downstream, from that table gonna be wrong. So I have to go back and then correct everything.
I
And
know.
you cannot do that without a lineage, right? Yeah.
Cool.
So I have to admit that I made many mistakes with the vocabulary, with the concept, like especially the local concept.
Mm-hmm.
So we create a concept and then we use that in many tables and we make a lot of mistakes on that. Yeah, so first of all, that this concept, you can see here that it is used in many tables downstreams.
Mm-hmm.
And if you make any mistakes there, it's gonna propagate, right? Yeah.
Thank
So
you.
this is very good too. Yeah.
And one more question about the implementation. Like since I work at the hospital like you, what would be your advice when starting a pilot implementation? Like any advice for people who works for a hospital and just think this SQLMesh is really good tool?
Yeah, advice would be, I think, like, well, I think it depends on the regulations that you, like the security teams want to place on like, introducing new tools to the hospital, right? Because most of the time, like hospital doesn't want you to have Python script running rogue on the server. So what we try to convince, my team, we kind of have some, like, you have to talk to like upper management about security and stuff, right? And the nice thing about SQLMesh is that it doesn't connect to the internet.
Yeah.
So you can just download the script, right? And everything's runs locally. That means nothing go to the internet. So everything I showed earlier runs on my local machine. I can, cut my internet and it still runs like I showed you earlier. So I think that's one thing that you have to think about. And what else? Yeah, set up the GitHub and yeah, like I did in the demo, for example, or yeah, we have this GitHub and yeah, we have our contributor, our team contribute to the GitHub, for example, and what else? Yeah, so I think that would be my advice, and also go through the documentation. I think that would be really helpful, and they have like a tutorial that you can follow there as well. Yeah.
Yeah.
Thanks, Johan. I actually had one more question, maybe more towards the mapping process itself, right? We saw how once you've got the mapping plan, then we proceed to the ETL phase, which is essentially what we demonstrated today. I remember we used perhaps a bit of Claude LLM during last year's OMOP mapping. Maybe we can talk about it another session. Right? We just wanted to get your thoughts. How was your experience like using the Claude LLM to do OMOP mapping? Yeah, in terms of accuracy and the ease of that. Yeah.
Well, I didn't tie that with my real hospital data because I don't want to put my real hospital data into the internet. But you can also try. I think nowadays, like the local model, you can download LLM and run on your local machine. I think a lot of like the DeepSeek model that you can run locally. I think it's, if you prompt it well, I think it's gonna do fine. I think it depends on how you prompt it. And also for the demo here, I actually used GitHub Copilot to modify the code from dbt to SQLMesh. Well, it helps a lot, but can still introduce a lot of mistakes. But because I know SQLMesh, I can intervene and then, okay, you have to do like this or like that. So I think after all, when you use this kind of tool, you still need to have some expert or expertise or understanding of what it's doing. But it saved a lot of time. I have to admit that I just did this demo like 6-7 hours ago. You can see all my commit message, and it's if without the tool, I think it's gonna took me several days to finish this demo.
Yeah, thanks, Max. Yeah, I mean, we can see AI's potential, right, in terms of scripting, even in terms of OMOP mapping. I think there's a lot of potential there. Yeah, we can perhaps have another session another time, right, covering more about AI's application in OMOP CDM conversion. Yeah. Otherwise, I think it was very helpful. Any last questions? We got 3 minutes left. Yeah.
I can quickly share like the script that I used to generate. So you basically in Visual Studio Code you can have a GitHub Copilot. I think there are many tools that many IDE like Windsurf or Cursor that do this similar function. So you have GitHub Copilot, and then I just asked it to convert, DBT to SQLMesh, and I give some example, and it just run it, and I have some, like take this script as an example, and then convert DBT, to SQL, and then it just, convert these 17 files. It's not perfect, it's not perfect for the first time, but I just, like go in there and then, okay, you have to change this to that, and then it works. But again, I wouldn't do like pass all the private information to the like this online tool so much. So make sure that you have, private information stored elsewhere, not on this code base.
All right. Yeah. Thanks, Max. Okay. I think we're good for today. Thanks so much for all the inputs, and I think good questions as well. We were getting some thoughts and feedbacks. Otherwise, yeah, thanks for everyone's time. We will connect again in about 2 weeks' time for our community call. Yeah. All right. Thanks.
Thank you.
Thank you.
Thank you.
Thank you,
Bye.
Mukesh.
Thank you.
Bye.
Bye. Thank you.
Have a good one.